Welcome to the Heating Cables presentation, where we're going to be covering self-regulating constant watt and mineral insulated cable. My name's Rob Zarillo, and I've been with Liberty Electric for over 10 years now, with over 14 years of combined experience between both the mechanical and electrical segments. At this point, I've worked on probably over 500 different applications regarding heat cable throughout upstate New York. Right now, my primary responsibilities are focused mainly with the engineering and architectural communities, supporting our larger electrical and mechanical contractors, and ensuring that our education is getting out to the street level regarding both design and installation of heat cable. Liberty Electric has been a leader in the electric heat community for over 30 years in upstate New York. Our agency began with a focus mainly on electric heat applications. And since then, we've added a tremendous amount of product line breadth to cover many industry applications. In 2016 and 2015, we acquired and merged with Empire State Sales and Ager Sales, and then acquired and merged with Eastern Reliability in 2018, giving us a foothold in both the electrical commodities market and tank heating applications. Our main office is in Syracuse, New York, and we're supported with 5 outside sales reps and 6 inside sales and support staff members, including Ed Jordan, who is specifically there for heat cable application and support. We call on a diverse audience that includes architects and engineers, again, electrical and mechanical contractors, wholesalers, industrial and institutional accounts. So today's agenda, we're going to be covering self-regulating cable, constant watt cable, and mineral insulated cable, which comprise the 3 most popular heat cables you'll find. So let's begin with self-regulating cable. Self-reg cable is the most versatile cable choice. It's relatively easy to work with. It can be cut and spliced in the field, and is generally price pointed as one of the more inexpensive cables. Because of the fact that this cable limits its wattage output, it really makes it a very strong choice for about any application. Self-regulating cable really gets its name through expansion and contraction of how this cable reacts to the surface that it's up against. So we're going to talk a little bit more about how this cable will contract and expand based on the temperature of what it's up against and vary its wattage output. When we discuss self-regulating cable, they get categorized in wattage outputs per foot. Typically, you're going to see the most common being a 3, 5, 8, or 10 watt a foot cable. These cables can be designed with much higher wattage output that can exceed 22, 25, and even all the way up to 37 watts per foot. This categorization or how we classify wattage output is all a manufacturer standard across the industry level, that at 50F, this is what the cable's output is going to be. So what happens is, as this cable begins to be put against surfaces that are colder than it, it's going to constrict and pull in those bus wires and heat the cable up. But the industry standard, we're going to get into that in the next slide, is based off of 50F. Other factors with cable construction that can determine output include the irradiated carbon content as well. Generally, your higher wattage output cables are going to have more carbon content within them, which helps ramp up that temperature. Another thing that makes self-regulating cable extremely popular is that this cable can touch against itself without fear of it burning through. Because it also regulates and varies its wattage output, this is going to be your most efficient cable choice. But typically these cables, for a low temp self-reg cable, is never going to exceed an output temperature of 150F and will destroy itself at 180F. These cables are also a class 1 Div 1 categorization, or can be, but most of them for commercial use would not have to entail that specific code requirement. So when we look at the anatomy of a self-regulating cable, we've got 2 parallel bus wires. Typically, they're 16 gauge that are going to be bound together by this irradiated carbon mastic, okay, or carbon black. This is really where all the magic occurs in the cable. Then you've got a primary overjacket to encapsulate both that carbon mastic and the bus wires. A tin copper overbraid is also put on there as both a means of protection for cut resistance, but also as a grounding means for the cable itself. And then typically your overjacket is going to be either a UV resistant jacket for roof and gutter application or chemical resistance for industrial application with caustic piping or acid piping, anything that can eat away at the jacketing of the cable itself. So some of the limitations of self-regulating cable, the biggest is inrush current. We're going to talk in the next slide about how we factor in circuit lengths for these cables, but we have to always be wary of the potential heat output of this cable. It's not necessarily what this is going to deliver on a day-to-day basis in the application, but it's what its maximum wattage potential is, which limits it in its circuit length. All heat cables are going to be single phase only, but maximum exposure temperature is also a limiting factor with these cables. At this point, the highest that I'm aware of is about a 550 F exposure temperature before this cable breaks down and destroys itself. The thing about self-regulating cable as well is that many of them have a limited life expectancy. The longer they operate, the more that carbon mastic begins to wear down. Now, there are manufacturers that can separate themselves from others, and that your more premium brands are going to have a much higher life expectancy because their irradiated carbon mastic has been refined over time. Typically, though, we figure about 10 to 15 years on average with controls operating them is about the typical life expectancy before we start seeing a diminished wattage output. This is also easily determined by taking a resistance check on the cables after about 8 or 10 years of use to determine whether or not they're still putting out full output, full heat output. The end seals are also not generally designed for any sort of direct immersion into water for sustained periods of time. Now, because these cables are used for roof and gutter application, it's not that they can't take water. We just don't want them submerged in a puddle for weeks or months at a time. Eventually, that water pressure will find some kind of seam into the end seal and could result in shorting the cable. Self-regulating heat cable is also generally not designed for voltages over 277. I believe there are a few out there that can deal with 480 volt systems as well, but generally 99% of this market is going to be 277 volt or under. And as we talked about earlier, the limited circuit lengths based on voltage, it really depends on, how much amperage we can supply to the cable, but in designing these circuits, we're not exceeding a 30 amp 2-pole breaker by design. So we're going to cover what those maximum circuit lengths are. So in this slide, we're going to talk about, again, what we just discussed with maximum footage per voltage used. And this is all based off of using a 5 watt a foot cable for sample, because that is the most popular wattage output self-regulating cable that we generally see in the industry. So if we take the math is pretty simple. I mean, basically what we're doing is with a 5 watt a foot cable, you have the potential to draw up to 12 watts a foot on that cable. So in sizing a circuit, our math has to be based on 12 watts a foot, because when the cables are started on a contactor, you're going to get a millisecond inrush current that'll spike that wattage draw on the cable, and then it immediately drops down to basically its desired operating range. Okay, but initially, if you have, say, 400 foot of cable on a circuit, it's going to spike at 12 watts a foot for a split second, which can cause nuisance trips on your code requirement GFI protected circuits. So at 120 volt, what we're doing is taking 12 watts a foot times 275 feet and dividing it by 120 volts. And it's going to come out around 22 to 23 amps, which again, we can't exceed 85% rated duty of the breaker by code, per NEC code. So we can limit this cable length to about 275 foot per circuit. And we're just doing the same computation based on these other voltages that you see below. So if we use 277 volt at the high end, what we're figuring is 525 feet times 12 watts a foot divided by 277, and that still keeps us under acceptable range for that breaker. Constant wattage cable is exactly what it says it is, and we're going to talk about this cable now. Constant watt is another cable that is pretty versatile and easy to work with, and pricing-wise, it's very similar to self-regulating cable. Constant watt cable is extremely predictable because, again, our rating system, whether it's a 4, 8, 12 watt a foot constant watt cable, it's going to deliver exactly that output per foot. Typically, this cable is used more for metal pipes and pressure vessels or tank heating applications where we're against another metal surface, okay? This is not a cable you want to use against a PVC or plastic-based material because, again, it's going to give you a consistent temperature output of whatever wattage per foot the cable is. Self-regulating cable can pull itself back some, so it doesn't heat up usually too much to the point where it's warping asphalt shingles or plastic material, but constant watt's a little bit different animal. This is not the type of cable that's rated for roof and gutter usage beyond 5 watts a foot, beyond 5, maybe 6 watts a foot. Generally, we need to have a product up there that can reel itself back on roof and gutter applications because this can eventually get too warm and embed itself into the shingles. So we look at a constant watt cable. Again, your more typical sizes are going to be like a 4, 8, or 12 watt a foot. These are simply just 2 bus wires joined together with a nichrome resistance wire. And the tighter we make these wire wraps, the more wattage output we're going to get out of the cable. The nice thing about constant watt cable, though, however, is that this stuff will take 480 volt application voltage, which self-regulating cable typically does not. And this cable also performs at higher temperature ranges and can actually take up to almost a 400-degree maximum exposure temperature before melting the jacketing and failing the cable. This particular cable can also be used in explosion-resistant applications, Class 1, Div 1, or Class 1, Div 2 applications, groups A, B, C, and D. So when we look at the anatomy of this cable, again, we've got, as discussed, two primary bus wires that are wrapped together with that nichrome resistance wire. What's interesting to note, though, too, is that the resistance wire, that nichrome wire, is actually a 37-gauge wire, which is thinner than a piece of dental floss. And when you think about being able to push 480 or 277 volt through that cable, it's kind of remarkable that it holds up for as long as it does. This particular cable's got a very similar life expectancy to self-regulating cable. I would bet that anywhere from a 10 to 20 year life expectancy range is very typical for these. Again, as discussed too with the self-regulating cable, you've got a primary over jacket along with a tin copper over braid to help for grounding measures and cut resistance, and then typically a UV resistant or chemical resistant. It should be more chemical resistant jacketing over this particular cable, as that's where you're going to find more of its applications is on pipe tracing. So an advantage of constant watt is the fact that it can go up to 480 volt, okay, and the fact that you don't have any of that inrush current nuisance that we have with self-regulating cables. As you recall, with a self-regulating cable, we have to figure out what's the maximum pull of that cable and compute the circuit sizes based on that. With a constant watt cable, it's a lot easier. If we're dealing with an 8 watt a foot cable, it's simply 8 watts times however many feet you want to put on that pipe, let's say, divided by your voltage. That gives you your final amperage reading, and either it fits on your breaker or it has to be broken into 2 circuits if it's exceeding the rated duty of the breaker. The limitation of this cable, the biggest, is the fact that this cable cannot touch itself. This has no means of pulling itself back, throttling itself back, and because it works at a higher temperature range, it will burn through itself. So we have to be careful when wrapping valves with this particular cable or using it in applications where there's the potential for it to touch against itself. A lot of times you'll see constant watt cables used in things like floor warming kits, frost heave prevention, sidewalk snow melting, and in those cases we cannot have these cables very close to each other or it will damage itself. Now, an important note also to note with constant watt cable is that due to the construction of the cable, there's what we call a node about every 2 to 5 feet, depending on who the manufacturer is. And when we cut a piece of constant watt cable, we lose its heat output until you get to the next node. So, for example, if we had a 2-foot separation in node distance, on a given piece of constant watt cable, depending on where it's cut, let's say it's cut directly in the middle, for 1 foot of that cable, you will have no heat output until you get to the other side of that node, and then your heat will begin again. This is actually a bit more convenient than people think, because when you install this cable, oftentimes there'll be a little bit of exposed cable possibly coming out of a power connection box, and we don't want that being as hot to the touch as to where somebody could get harmed if they were to accidentally touch the cable itself. But once you get back onto the pipe again, you're heated and again, properly protected on the pipe. So mineral insulated cable is the final one we're going to talk about a bit here. MI cable is a very rigid, very robust form of heat cable that it actually seems more like a tubular heater. It retains its memory when it's bent. This is a cable that is capable of extremely high wattage outputs, but when we're talking about this cable, there's some guidelines that we're going to cover that limit it a bit in its application. But overall, this is a permanent type of heat cable solution. This form of cable can last upwards of 30 years. And as you can see, some of the limitations are we generally want to keep our runs under 400 foot of this particular cable. But it's important to note also that these cables are literally built to order. These are designed, engineered, and manufactured very specific to the application. There's 2 different kinds of MI cable. There's single conductor and there's 2 conductor, and we're going to get a little bit more into the anatomy of these cables in some forward slides here, but this is not the type of cable that could easily be worked with out in the field in terms of cutting, splicing, or repairing. Because it's a metal sheath cable with either a copper or stainless steel jacketing, there's quite a bit of finesse that's involved in actually working on this particular type of cable, especially out in the field. It should only be done by somebody that is 100% qualified to do it. This type of cable, though, adds a lot of versatility in terms of application, is that because it's a moldable type of heating element where we can retain that memory, we've actually used these cables before to surround sump pits for de-icing. We've used them in pavement snow melting, which is the most common application for these. They can actually be used for roof and gutter de-icing. We just basically engineer a lower wattage output so that it's safe to put against roofing material without fear of it melting in. So again, to talk a little bit about this cable and its attributes, it is a constant watt cable by nature. So even though we can engineer a particular wattage output for it, you're going to see a constant wattage across the entire length of that cable. So it's going to behave exactly like what we just discussed in that prior segment. So again, we don't have the nuisances of dealing with circuitry like we do with self-reg cables, where we're looking at what's a potential wattage output for it. Because again, it's a metal jacketed cable, it is a lot more robust. It can typically handle things like a razor knife going through insulation that accidentally touches the jacketing of it. Though we want to make sure that our cables are being measured all the time while they're being installed in any application, these will hold up a whole lot more to somebody, say, stepping on one of them or accidentally nicking it with a razor knife. Another big advantage to this cable is that it can go all the way up to 600 volt range. So it has the widest range of applicable voltages to it. And same thing with temp ranges. This stuff can go all the way up to about 1,400 feet before heat will cause failure on the cable itself. Because these are pre-welded and they're terminated during manufacturing process, these are excellent for explosion resistant applications and for direct water immersion. These cables, when they're produced, actually have to, per code, survive a 24-hour dunk test in a tank, in a water tank, to ensure the fact they're fully sealed, which again is exactly what we want, is spark quenched for explosion resistant applications, or obviously for direct water immersion. These things have to be 100% tight. So when we look at the anatomy of this particular cable, very simple actually. We've got either a single or two heating conductor core, and the white layer that you see there is a magnesium oxide powder. And this powder, during the manufacturing process, is shaken at a very high vibration rate to compact it very solidly around those heating cables. So this really provides an insulator around the heating conductors themselves. And then you're simply wrapping this in either a copper seamless sheath or a stainless steel jacketing. An HDPE over jacketing is oftentimes used in applications like roof and gutter, or in more specifically concrete immersion applications, where we need to protect the copper surface from the curing chemicals used in sidewalks or in concrete pours to help accelerate concrete drying. Unfortunately, the solvents that are used within those drying chemicals can attack the copper and oxidize it over time. So we use an HDPE jacketing mainly to just protect that cable during the time that the concrete is wet. When it's dry, there's no issue there. And many times in a concrete application, the HDPE over jacket will burn itself off within the first use. So this is a diagram or a picture depicting a typical assembly used for a sidewalk snow melting application. As you can see on this particular one, it's a two-conductor where you see the THWN cold leads coming out of the back of it. When you have two pigtails coming out of one end of the cable and there's a sealed end cap or end seal on the other side of it, that is a two-conductor cable. If this cable were to show one pigtail coming out of each end of the cable and no pre-terminated or welded end seal on the end of it, that would be considered a single conductor cable. Now, single conductor, you have to bring both pigtails back to the power connection for the cable to be fully energized, which makes it a little trickier to install out in the field. A two-conductor cable, it costs a couple bucks more per foot, but it's well worth it during the installation because, again, your power connection just comes in on the two cold leads, and you can leave the end seal wherever you need to in a concrete pour or along a pipe. So again, the advantages of this particular cable are that it can withstand extremely high temperature exposure, and it can deliver very high temperature outputs. We can go with longer circuit lengths on this, but they do become a bit more unmanageable for the installing contractors in many cases because of this cable's weight. This is not coiled around a typical wire spool when you accept it on a job site. These usually will come wrapped in a hoop, and they become a bit harder to handle if you're 30 feet in the air and a bucket truck trying to put this stuff on roof and gutter applications. So depending on that application, we try to size the reels accordingly, let's say, or the hoops accordingly. It is a very long-lasting cable. This is something that provides a lot of permanence in sidewalk snow melting or again, roof and gutter pipe tracing applications because of its robust nature and 30-plus year life expectancy. And again, as we discussed earlier, it's a good choice for explosion-resistant applications because it's pre-sealed. So some of the limitations, the biggest limitation really is the fact that you must be exact on your lengths with this particular cable. This is not a product that's going to allow itself to easy field repair or trying to add an additional 10 or 15 feet to it in the field. This cable, because of its really strong jacketing, that metal jacketing on it, it's not the easiest cable to bend or to work around tight places or to try and get it to lay perfectly flat in these applications. So it does take a bit of finesse to install this. And typically, because of the fact that we're dealing generally with higher wattage outputs and it can quickly overwhelm a supply service, we're generally looking at shorter circuit lengths with these particular cables. So in summary, this gives you a good basis and some information on what separates these particular three cable types from each other and where they're best suited for their applications. Again, just to recap, self-regulating cable is bar none the most popular heat cable choice used across many different applications. About the only application that we feel it's probably not best suited for is concrete immersion sidewalk snow melting, due to the fact that many of these cables have a limited life expectancy and that their wattage outputs actually diminish once they've heated up. When we look at constant watt cables, these are fantastic for metal pipe tracing and can actually be used in frost heat prevention, sidewalk snow melting applications, and some limited roof and gutter application if we've got the proper wattage output considered and controls. These can be successful cables, absolutely, for a roof and gutter application. Mineral insulated cables, again, very versatile in terms of the fact they can be used for tracing airplane hangar doors. We've used them on railroad track switching mechanisms to keep those de-iced. They can be used in roof and gutter applications, sump pits. I mean, again, this is a very versatile type of product, but we have to do our homework on this one to make sure that we've got the proper lengths, we've got the proper cable and the right heat outputs to make sure that your project is successful. So hopefully you picked up some tips on this, and certainly if we can provide any other information or clarification, please give us a call at Liberty Electric. We're happy to help you.